Right, in this video we're going to talk about Feynman diagrams. Now, we're going to jump straight into this Feynman diagram. So this is an electron path in time. So this is one electron's path in time. So time is acting in this direction here. And so what we can say is that in this circumstance, the electron comes in and gives off a photon of energy. Now, where have we seen electrons giving off photons of energy? Hopefully you remember. Energy levels, electrons up on higher energy levels, when they drop down, they give off a photon of light. And this is a representation of that interaction there. So effectively, we can show particle interactions, such as this one, using Feynman diagrams in time. Now, one thing I will say is that we don't really have a y-axis here. This is not a spatial arrangement of particles. We cannot use this diagram for vector resolution or anything like that of these particles. It is simply an opportunity to show that the electron is coming in, emitting off a photon, and traveling off in time. So this is a time axis. So, I mean, the electron could not be moving. I mean, it likely is to be moving, but the point is that this is not showing movement. Okay. So let's have a look at another example, one that you will be familiar with, which again shows something very, very common to you all. So instead of, we've still got our electron moving through time. So instead of our electron emitting a photon, what else can electrons do? Remember the energy level diagrams? Electrons can go up energy levels. How do they go up energy levels? Well, they do that by absorbing a photon. Well, here we can show that absorption here. And that is a Feynman diagram of an electron being, an electron absorbing a photon. Now, what I want to point out is this particle right here, photons. And we've talked about photons quite a lot in this course, but a photon is a type of exchange particle. And that exchange particle, there are a number of other exchange particles, but this particle is what mediates the force in this case here. Now, this forms up part of a group of particles called bosons or gauge bosons, because they mediate interactions that go on in the world around us. So let's have a look at another example that you might like to point out, and that will draw on this idea of using photons. So here is another example. Electron. But we've got another electron. Now, as you well know, electrons, because they are negatively charged, repel each other. And so they exchange a photon when coming close to each other, and that mediates the interaction that's going on here. This is an electrostatic interaction. So this electrostatic interaction is being governed by an exchange particle, which is a photon. Now, one thing I will point out about exchange particles is they're also usually called virtual particles. Mostly because the virtual particle in this circumstance, because we don't really observe them taking place, we can't see an electron and another electron and they go boom, we see a photon of light being exchanged between them. No, we don't see that happening, but we are saying that there must be an exchange here of something in order to cause this electrostatic repulsion. Again, please bear in mind that this is kind of a spatial arrangement, but we are not using it to represent that intrinsically, okay? It is just an indication of what interaction is going on in time, okay? So photons are the exchange particle which governs electrostatic interactions. So what about any other interactions then? Well, there are a number of other interactions that occur, and we will talk about those in the next video.